Academy of Arts and Sciences and a foreign member of the Chinese Academy of Sciences. Let's give Professor Zhang a warm welcome.
Thank you very much and good morning. I feel especially excited to come here because of the two topics are both of my passion. One is Einstein. Maybe you don't quite know the history. It was actually founded in my home. The very first meeting which started in Einstein. And the second topic of my passion these days is of course blockchain. So, it is up. Okay, so okay. So we are in a very exciting moment in history that, as many of the previous speakers indicated, we're really in a moment in history where we find really a new technology which will fundamentally change humanity. We talk in terms of things like value exchange and medium of exchange. So in order to understand this exciting future, I'd like to invite you for a journey to the past. Basically, I think the blockchain revolution is much deeper than some people have originally thought. It basically is an approach which will bring natural sciences and social science back together. We always think of natural science being very, very precise, and social science, and especially economic science, very vague. But with the revolution of blockchain, I think these can finally converge, and that will really bring tremendously deep understanding of economics itself at that age. So I'd like to start by giving an analogy to help us to understand the idea of a medium of exchange value. So I'd like to invite you to consider an example in physics. So originally, when we talk about things like gravitational interaction or electrostatic interaction, we, for example, have charges which are separated far from each other, and they have the property that the like charges repel and unlike charges attract each other. And they're described by Force law, which is acting at a distance. Even though these two particles are not touching each other, they are actually interacting with each other by a force which is long-ranged. But if I have n particles, I will require n squared, roughly n squared type of interaction between every pair of these particles. And that's very, very inconvenient. So afterwards, people invented the idea from particle to the idea of a field. So I don't say that one particle is acting on another particle at far distance, but rather I say one particle generated a field, for example, in this case, an electrical field, and that electrical field in turn acts on another particle. So this way, the interaction becomes local because one particle generates a field in its immediate vicinity. That field propagates and then acts on another particle. Also, it makes the description much easier because then one particle is just interacting with a field. So if I have an n particle, I only have n such interactions. Whereas if I have pairwise interaction, I will require n squared such interactions. So, but this originally this idea of a field was introduced as an auxiliary concept, but later it becomes very useful. So this analogy, why I'm talking about this in the context of blockchain or in the context of economy. So this idea of transforming from a pairwise interaction between particles to an interaction through a medium, namely a field, is very similar to the transformation from a barter economy to a monetary economy. So in the very early days in human civilization, we don't have the concept of money. We only do pairwise exchange of goods. For example, my fish exchanging with your apple. So this also requires n squared such interaction, which is highly inefficient. Furthermore, you will require something which is called a double coincidence of wants. In order for this exchange to happen, I have to happen to want your apple, and you have to happen to want my fish, and that may not always be the case. So such an exchange is highly inefficient, just like I described earlier. To describe the pairwise interaction between particles is very inconvenient. But later on, human civilization invented a new concept, which is a medium of exchange, which is money. So in this case, I don't exchange apple with fish, but I exchange apple to money and money back into a fish. And that economy becomes much, much more efficient. So this analogy I find in some sense very precise, going from market economy to a monetary economy and going from pairwise interaction between particles to the interaction from particle to field and then from field back to particle. But still in the early days of science, the idea of a field was viewed as a fictitious concept. It's something that's useful for bookkeeping, but people really don't understand whether it is has an intrinsic physical meaning or whether it has intrinsic value. So that actually moves us to the next slide. Actually, one of the greatest revolutions in science is to understand that this concept of field is not auxiliary. It has intrinsic meaning and has intrinsic value. So many of you know, recognize the picture of Albert Einstein. Many of you know that he's famous because of his theory of relativity. But he did not receive Nobel Prize for his invention for the theory of special or general theory of relativity. He actually received Nobel Prize exactly for assigning a value to the field. Now, what is value in the physical world? The universal value in the physical world is energy. This is the value with which particles or physical entities exchange their value. So Einstein basically invented a formula for assigning a value to the electromagnetic field. So for example, different lights are different forms of the electromagnetic field, and red light will have lower energy than blue light. The shorter the wavelength, the more the energy. And this is the Einstein formula. So this is a tremendous step in the revolution in understanding of the concept of the field, something which was originally introduced as an auxiliary concept, helpful for bookkeeping, but originally we didn't think it has an intrinsic physical value. But after Einstein's work and one great revolutionary step that took place, we finally understand that the concept of field has intrinsic value of its own. Next page. So then when we talk about money, what is the intrinsic value of money? Why does it have some intrinsic value? So let's, for the sake of argument, compare about two possible medium of exchange. One is apple, let's say, and the other is gold. Let's, for the sake of argument, assume that the gold doesn't have any intrinsic value. We don't even use it for industrial purposes or for jewelry purposes. But actually, Apple has, so we can use Apple as a medium of exchange. Let's say in a primitive economy, we exchange everything into Apple as a form of money, and then exchange everything back from Apple into some other form of goods. So Apple actually could have also have a commodity value. Besides serving as the purpose of money, it could, we can actually eat the apple. It has some commodity value of its own. But as the intrinsic value of money, Apple is far worse than gold. Why? Because under the concept of one apple, we understand many, many different things. Apple can be a red apple, can be a green apple, the apple can be ripe, it can be already close to corruption, and so on and so forth. Basically, under the concept of one apple, we understand many, many different things. So in the curve, you see that the concept of apple has very, very broad distribution. Many people understand under the concept of apple many, many different ways. Especially in an economy, there has to be different parties, those that produce apple, those that consume apple, and those who simply use apple as medium of exchange. But those who produce apple and those who consume apple may assess the value of apple much better than those who simply use it as a medium of exchange. So therefore, if different people assign different values for under one apple, it's not very convenient to use this as a medium of exchange. So something that has a very broad distribution would actually not be useful as a medium of exchange. On the other hand, a concept of 1 ounce of gold, people understand very, very precisely what is meant by 1 ounce of gold. The next page. And that is because of the work of two very famous physicists. And one is Archimedes, and the other is Isaac Newton. You may all know the story of Archimedes, that he was given a task by the king of Syracuse. Some handyman fashioned a crown, a golden crown for the king, but the king is very suspicious whether the crown is really made out of actual gold or not. And he gave Archimedes the task to figure out whether the crown is made of all gold. without destroying the crown. So Archimedes was very, very perplexed by this question: how can you possibly assess whether a crown is made of true gold without destroying the crown? So when he got very depressed, he took a bath, and in the bathtub he suddenly had a revelation, and he shouted "Eureka!" And the story runs that he ran naked to the king and telling him the solution. So actually the solution is very simple. You take a golden crown and you take pure gold, exactly of the same amount, so that the balance, the scale balances in here. And then if you put that same scale into the water, actually you find that they no longer balance. Actually the gold will sink down and the crown will go up, flow down. And that's because if they are made of, if the golden crown is made out of different material, for the same weight, it will have larger volume and it expels more water and gives more of a floating force. So with this brilliant idea, he can actually assess whether something is made out of true gold or not. So this actually gave tremendous reason for why gold was adopted early on to be the monetary exchange, precisely because of the argument I gave earlier. Because under the concept of 1 ounce of gold, we can actually measure very precisely whether a piece of metal is actually made out of 1 ounce of gold. But later, when gold coin was circulating into the economy, and we have gold coins, some other problem start to arise. So you may all know Isaac Newton being a great, famous physicist, but after he became famous, he got another job from the Queen of England. He became the master of the royal mint. So he controls the manufacturing of the golden coin. But when the golden coin went into circulation, different people tried to get something extra out of a golden coin by rubbing its edge to accumulate some extra gold. And when they do this enough times, let's say 100 times, they get 1 extra golden coin out of it. So this actually gives rise to a non-consensual meaning of 1 piece of gold coin, because it could be a piece of gold coin that has been rubbed off a little bit. And it was actually, when you pick up your coin, you all see these stripes on the edge. This was actually invented by Isaac Newton as the master of the royal mint. So by putting these stripes onto the edge, when you rub it off, you immediately see that somebody was cheating. So therefore, with this invention, and not only we understand very precisely what is meant by 1 ounce of gold, we also understand very precisely what is 1 piece of golden coin, because its value has been, it can be measured better. So therefore, the key value of money, and these days we even have 1 piece of paper representing money. But we all understand 1 piece of paper, $1 being exactly $1. We have very precise meaning of its, we have consensus about its value. So we go to the next page. So therefore, the key and intrinsic value of money is the consensus about its value. We understand we have not consensus about what is meant by 1 apple, but we have very precise consensus about what is 1 ounce of gold or what is 1 piece of golden coin. So a consensus is something which has very, very narrow distribution of its meaning, and something that's not consensus has very, very broad distribution of its meaning. And that has analogy in the physical world. Let's say actually everything is made out of electron, and the electron is acting like a little compass. It actually has a north pole and a south pole, just like a compass magnet. But most of the time, a piece of material don't act magnetic. And that's because the electron spin, being like a little compass, is behaving more like on the right. It's pointing all in the random directions, and it does not have well-defined global, they don't have consensus about the 1 common direction to point to. But we also see another phenomenon. Every time you go to your refrigerator, sometimes you like to stick a magnet on your refrigerator. So what's happening inside the magnet? What's happening inside the magnet is that every electron, being like a little compass, all have consensus about 1 direction to point to. So basically in the magnet, all electrons point in exactly 1 direction. And that's why globally this material acts as a global north pole and a south pole, and that's why you can stick on your magnet. So that's why we see that in the physical world, these unconscious electrons can somehow decide collectively onto one direct to point to, and namely reaching consensus. So, and we just argued that consensus is the key meaning of money. In order to have monetary exchange, we have to have consensus about its value. And that brings me to a concept which is very fundamental, which is called entropy. In a state when the magnet is all pointing randomly, it is a state of high entropy. And in a state when the magnets, the electron compass, are pointing in one uniform direction, it's a state of low entropy. Basically, there are many, many ways to be random, but very few ways to be in consensus. So as time evolves, usually entropy increases. Go to the next page. So, but even though in the natural world things tend to be more disordered and things tend to be more random, but still under special circumstances, order can happen with more disorder. So I already gave the example that these unconscious electron spins can somehow avoid being in this random state of high entropy, but they can actually achieve a state of low entropy with uniform consensus about one uniform direction to point to. There are also examples in the biological world that things can act collectively in an emergent and self-organized fashion. So on the right you see the picture of bacteria. All these bacteria are most of the time acting quite randomly. But they also communicate with each other. They communicate with each other by emitting some molecules which can be received by other bacteria. And by this communication, they can basically measure how many other bacteria are nearby. So there's a particular type of bacteria called bacteria Fischeri, and so when they see enough neighbors in their surrounding, they suddenly decide to light up. Suddenly, all these bacteria will start emitting light, and it's actually a beautiful natural phenomenon. So this actually tells us that even though these entities are totally unconscious, being electrons pointing most time randomly, and bacteria acting more or less independently, they can still reach a global consensus in a self-organized fashion. Next page. So if this can be done even in the natural world without actually have conscious entities and without having a global master telling this electron what to do and telling this bacteria what to do, they only interact with each other, and through a self-organized fashion they can reach a consensus. So now let's move to the world, from the physical world to the world of computer science. So it has always been a famous problem in computer science that if I have a distributed system where every computer is acting more or less independently, whether they can reach some sort of global consensus in a way that we want to ask them to act collectively. So this has always been a problem that has been puzzling, and the search was to look for some kind of a master deterministic algorithm which can tell all these computers which are behaving quite independently, and some of them can even behave maliciously. And in this context, whether you can globally have consensus among a distributed system of computers. So actually people tried, and they always failed. They couldn't find a global master deterministic algorithm which helped all these distributed computers which behaving on their own way to reach a global consensus. And then three great computer scientists finally proved the theorem. This is called the Fisher-Lynch-Adalynn theory, which says that such a master deterministic algorithm is actually not possible at all. And that actually finished the search. So if you actually have such a deterministic master algorithm, it will be like in the world of physics, that you can actually reduce entropy without any cost. And that we know that in the world of physics is actually not possible. So therefore, in today's blockchain world, we actually reach consensus so that all these distributed computers can agree on a global ledger. If we agree on a global ledger, just as I argued earlier, it's reducing entropy, and from the basic laws of physics, saying that overall the entropy always have to increase. So it's not possible just to reduce entropy by globally agreeing on a ledger without any cost. So one criticism about blockchain and Bitcoin, which I think is a shallow criticism, which says that it wastes so much energy that by the proof of work, in order to reach some global ledger consensus about global ledger, you have to do some computation, which wastes energy, which is the cost of reaching consensus. And some people use this as a basis to attack the Nakamoto protocol of proof of work. I think this is actually not a valid criticism. So when you understand what's happening in the physical world says the second law of thermodynamics tells you that globally the entropy always has to increase. So if you reach consensus, entropy is decreasing, so therefore you have to dump entropy somewhere else. And that is done in the blockchain world through the proof of work. But if you try to use some centralized entity trying to coordinate all these computers, actually, most likely the entropy increase will be much, much higher. Next page. So this Nakamoto protocol, or the protocol of reaching consensus through proof of work, is finally a new kind of protocol which enables a global consensus without in a purely self-organized fashion. And that can lead to a revolution, the likes of which we have never seen before. When you really look at the history of the world, in just the history of the world itself, but also the history of computing systems, it always goes through cycles of centralization versus decentralization. So in the very early days, when I first came arrived in the United States in the 80s, AT&T is such a monolithic monopoly that many, at least at that time, it looks like a monopoly which will never ever be broken. But it is a monopoly or centralization caused by a networking protocol which is called circuit switching. In the days of circuit switching, such a monopoly existence is very natural, and that's why AT&T, through a series of consolidation, became the centralized monopoly of all networking resources. But then a new kind of networking protocol came to place, namely the TCP/IP protocol. And once that new decentralized protocol emerged, immediately, almost overnight, the monopoly of AT&T was broken, and the networking world became totally decentralized. So I actually, also in Chinese, this wave of centralization versus decentralization, a constant cyclic evolution from centralization to decentralization, is a very nice saying in Chinese. It's called 分久必合，合久必分. So, but then all these networking resources gets fragmented, and the content also gets fragmented, and that's why when as we search for content, we need some more centralized entity to organize this content, and then the centralized platform such as Google and Facebook start to take place. So this centralized monopoly actually organizes all our data, or personal, sometimes even our personal data, into a centralized platform. And that could be extremely unhealthy for the further development. So what I believe, what blockchain technology will enable, besides being a useful platform for value exchange, is finally it could give data economy back to the individuals, so that we can all own the data. So that goes from 合久必分, it goes from centralized platform back to us. And then through this new blockchain technology, finally a data market can take place. So basically, I see the future of this new world. I have a very simple slogan for the future of this new world. It's called "In Math We Trust." So when you really look at, if we understand that the key fundamental value for a monetary economy is consensus, I can ask ourselves the question: among all knowledge of human creation, about which part of human knowledge do we have the most consensus about? Is it about political science? Is it about social science, economic science, physics, or what else? Actually, it is mathematics. We have the most consensus about mathematics. If we have a mathematical concept, it's simple and universal, it applies to all. So that's why it's so exciting about the new crypto economic world, because the very basic foundation of it is mathematics. And it's so natural because in the physical world, the most fundamental laws of nature are expressed into beautiful formulas of mathematics. And so far, the physical science always look very, very different from social science, but with the invention of the proto-economics, we finally reach a new era in the human development. And that era I call in math we trust. Now, what kind of math? Next page. So actually, it's very, very beautiful. And so we know that the ideas of private key and public key are all based on elliptic curves, which is one of the deepest mathematical concepts. The famous Fermat's last theorem was proved using elliptic curves. The one-way function of hash function allows the concept of proof of work to take place. There's a wonderful piece of mathematics called zero-knowledge proof. Namely, I can prove to you something that I own a piece of, for example, that I solved a piece of puzzle. I can prove to you that I solved this puzzle, but without revealing to you how I solved the puzzle, for example, a Sudoku game. And this actually could be a key fundamental piece of mathematics which will enable privacy-preserving computation in the data economy. There's also the idea of secure multi-party computation. The famous problem is called the millionaire problem. Two people try to compare their wealth to figure out who is richer without revealing to each other the actual wealth, the actual amount of wealth. And also formal verification, homomorphic encryption, and that the directed acyclic graph. So next page. So of course, one of the most exciting things, I think there are two exciting things which are happening in the world of information technology. One is blockchain, and is AI, artificial intelligence. And I predict that the future will be a symbiosis between these two trends in technology. Basically, AI we have heard about a lot before these kind of blockchain conferences were organized, even last year or the year before, every organized is focused on AI. Now, why suddenly people are not talking so much about AI? Because the progress in the last few years actually is quite slow. So now, why is the AI developing so slow? So the fundamental building block of AI lives on data. AI can only learn when we have enough data. But in the problem I alluded earlier, right now data are all in centralized, monopolized places, and that's very disadvantageous. What happened? So there's a very, so the data is not there for the AI to learn because there's not enough incentive for individuals to contribute to their data. So with the blockchain world, if the data ownership goes back to the individual, and if there are these mathematical primitives such as secure multi-party computation and so zero-knowledge proof, finally the data ownership can go back to the individuals, and with those privacy-preserving computations possible, finally a data economy can take place. And if the data economy takes place, individuals will be rewarded or incentivized in providing data, and finally this will make AI to work. So this, I also think, will finally enable the crypto economics world to function better than the current economic world. Because in the current economic world, there are biases against minorities. As everywhere in the society, we always face this problem of biases against minority. But in such a crypto economic data marketplace, when you think about what AI needs to learn is data. But if my AI algorithm is already, let's say, 90% accurate, the data that I need to learn further is not yet another kind of data which is similar to what I used before. In order to get my AI algorithm to be more accurate, I need to learn most from corner cases so that I can improve from 90% to 99% and then to 99.9%. So what I need most are these corner cases, but the corner cases are owned by minorities by definition. So finally, in this data marketplace, the crypto economic world can do social goods by turning an ugly duckling into a beautiful swan. Because the ugly duckling is not ugly, it simply is different. And the difference is actually most valued. It's discriminated against in the current economic model, but will be valued most in the future crypto economic world when data marketplace takes place. And go to the next page. and then skip that next page. Yeah. So then and then the next page. So I'm the founding chairman of the HPC, and so we actually predicted that blockchain is the most important revolution of our time. So we started investing quite early on in the blockchain world. So we try to invest systematically, understanding what are the key commanding types of the crypto economic world. And we started systematically deploying, so in things like stable exchanges, in stable coins, in exchanges, and in different application layers, and also in the infrastructure layer. Maybe let me single out one investment on the lower right corner, which is ontology. And this is our cloud investment. And even in the current bear market, they are doing extremely well. We have more than tenfold in the initial listing on the exchanges. So basically, this is the fundamental technology which enables the data marketplace to take place. Next page. So what do I think are the fundamental areas worth investing? One is the blockchain scaling solution. The other, a very, very exciting development. So starting from, for example, from one area we invested, it's a token called Theta, and that's tokenizing the networking infrastructure of content delivery. So it's tokenization of CDN, content delivery network, and this is actually a very, very exciting area. So I think that the blockchain value exchange layer and the fundamental networking layer can also exist in symbiosis with each other. The networking infrastructure can be much more efficient if it's tokenized, so that there are especially different layers of services depending on the tokenized incentives. I talked about privacy-preserving computation, and one exciting area for privacy-preserving computation is in the genomics and healthcare data marketplace. There could also be tokenized sharing economy and identity management. So I think we can leave at this slide, and that concludes my talk. So basically, in the last slide, I want to say that in the 1680s, Newton published his famous book called the Principia Mathematica, basically laying out the mathematical principles of the natural sciences. And finally, with the arrival of the crypto economic world, we can also have the mathematical principles which describe this economy precisely. And because we understand mathematics precisely, we can understand crypto economics precisely. And this is really the dawning of a new age for humanity. Thank you very much.